Friends, welcome to NG Academy. Today, our agenda is to discuss accommodation of eye, near point, far point, and range of vision. Let's understand science behind the accommodation of human eye. Accommodation here simply refers to adjustment of focal length of eye lens to form clear image of an object at its retina. Now let's understand some basics of human eye. Our eye is supposed to have biconvex lens made up of protein and is gelatinous. This structure is ciliary muscle that can contract, I mean to say it can shrink and relax. This red collar thread like structure is connected to the lens and the ciliary muscle at both the ends. Now let us go to the ray diagram to understand accommodation. This is our object at infinite distance from the eye. This is our eye. The light rays emerging from the object almost are parallel to the principal axis. It falls on the lens and gets converged to a point on the retina after refraction, and this point is called focus of eye lens. This is the focal length of eye lens, the distance from optical center of eye lens to the focus on the retina. Hence, the clear image of the object lying at infinity is formed at the retina. Now let us look at this figure number 2. This particular object lying at infinity now arrived at some distance nearer to the lens. This structure is the lens of the eye. See here, the ciliary muscle looks so smooth, but as the object approaches to this distance, I mean to say nearer to the eye, the ciliary muscle has shrunk a bit. When the ciliary muscle shrunk, then this red structure loses its tension and lens become little thick, I mean to say more curved. The lens has become more curved than this picture. Here see, you can see here the lens is more curved. Lens curved means its focal length decreases. Focal length means the distance from optical center. The distance from optical center to the focus now decrease. Here the focal length here, from here to here the distance is greater, but here the focus has shifted from retina to this point as the object approaches to the lens. Now one of the light ray emerging from object after refraction through the lens passes from focus and another ray passes through optical center. Both these rays meet at a point on the retina where clear image of an object is formed. Now let us move to the figure number 3. Similarly, as the object approaches nearer, the curvature of the eye lens increases. Here in figure 3, see the curvature. Okay, let us compare this figure and this figure. The curvature in this case, the curvature of the eye lens in this case has increased a bit as the object approaches nearer. Curvature increased means the focal length become more shorter than this. The focal length, let's compare the focal length of these two pictures. Here the focal length has decreased more than this. The focal length has become more shorter than before. Well friends, let's not forget, as the object approaches nearer, the ciliary muscles shrinks more than this, and the tension on this thread, red thread, is also negligible, due to which lens curvature increases, I mean to say thickness increases and the focal length decreases. Due to this adjustment of focal length by an eye, the clear image of an object is formed on the retina. At this point, we have to understand what is accommodation of eye, because we have already completed about the accommodation of eye. The process by which ciliary muscles functions to change the focal length of the eye lens so that clear image of an object is formed on the retina is called accommodation of eye. But friends, our normal eye can form image of object lying anywhere between infinity to 25 centimeter away from the eye, since this lens also has its compression limit. It also has its compression limit. I mean to say, ciliary muscle can press this lens only to certain extent. Beyond that, neither curvature of lens can be increased nor its focal length becomes shorter to get the clear image of an object on the retina. Now friends, let's see figure IV. Object is at 15 centimeter away from eye lens, but the eye lens is unable to decrease its focal length. See, eye lens is unable to decrease the focal length. This focal length and this focal length is same, but the object here is at 25 cm away from the lens. Here the object is 15 cm away, but the focal length is same. Why it is happening? Because this lens has compression limit. Okay. The two light rays that are emerging from this object after refraction do not meet at retina to get clear image of the object. So the image is blurred in this case. Now let's define near point with respect to this figure. The nearest point from the eye lens at which an object can be seen clearly by the eyes is called its near point. The near point of a normal eye is at a distance of 25 centimeter from our eye. Now let's define far point from this figure. See here, the farthest point from the eye at which an object can be seen clearly by the eye is called far point of the eye. So what is the far point of the eye? The far point of the eye is at infinite. See, this is infinity. Now friends, let's discuss about a range of vision. For example, this is your eye. Okay, I will draw rough. Okay, this is your eye. Okay, Now this is the principal axis. Now from eye to this point, this is 25 centimeter. Your object is at 25 centimeter away from the eye. Now the object, initially this object was at infinite distance. For example, this is infinite distance. Okay, the distance between, for example, this is at infinite distance. The distance between far point to near point which can be focused by our eyes is called range of vision. So this is the range of vision from here to here. This is the range of vision. The eye can see the object at this point also, and here also, up to this point the eye can form the clear image of the object at this retina. Okay, now below this near point, below 25 centimeter, for example, if it is at 15 centimeter, then the image of the object is not formed on the retina, it is from beyond the retina, and the object is blur. We cannot see it clearly. Okay friends, this is all about accommodation, near point, far point, range of vision. Thanks for watching the video.